Welcome to Formula 1 Maths. This is exercise 10.1, GCE A-Level Applied Maths, Year 1. Exercise 10.1 is on force diagrams. We've got 3 questions to answer. Question 1. The diagram shows a particle moving with velocity v. Find the values of P and Q. Now this particle is moving in this direction with a constant velocity v. So first of all, let's look at the vertical motion. The particle is neither moving up nor down. That means that the total forces acting downwards must be equal to total forces acting upward. So we can say that 6p minus 3q, which is the force acting upward, will be equals to 30 newtons, which is the force acting downwards. So we can write this as one equation and label that equation 1. Now we turn our attention to the horizontal direction. We know that the particle is moving in this direction to the right. So this force P plus 2Q is bigger than the opposing force, which is 25 newtons. According to Newton's second law of motion, which states that F is equals to ma, any resultant force, F, will produce an acceleration on a particle with mass m. In this case, the resultant force, which is moving this particle in this direction to the right, will be F equals to P plus 2Q minus the opposing force, which is 25, the opposing force moving that direction. But because the velocity is constant, it means there's no acceleration. So it means that A, acceleration is 0. So in this case, Newton's second law will be F equals to the mass times 0, which means F is equals to 0. But we have just found out that the resultant force F is equal to P plus 2Q minus 25. That means P plus 2Q minus 25 is equal to 0, which implies P plus 2Q is equal to 25. So we can use this one as another equation and label it equation 2. Now we've got 2 equations with 2 unknowns. So we can solve the 2 equations simultaneously to obtain the values of P and Q. So let's proceed to solve the 2 equations simultaneously by multiplying equation 2 by 6. If we do that, we are going to get, then we subtract equation 1 from it to obtain the following. This will yield 15Q is equal to 120. And solving for that, we give Q is equal to 8 newtons. So the value of Q is 8 newtons. We can now substitute the value of Q into any of the 2 equations over here, either 1 or 2. But it's easier if we use equation 2. So let's substitute the values accordingly. And we are going to get P plus 2 times 8 equals to 25. That simplifies to P plus 16 equals to 25. And solving will give P is equal to 9 newtons. So P is 9 newtons. And that is question 1. Question 2. Each of the diagrams show the forces acting on a particle. A. Work out the size and direction of the resultant force. B. Describe the motion of the particle. So if you look at the first one, we can see that this particle is neither moving up nor down because the forces acting up are equal to the forces acting down. But if we look at the horizontal direction, we see that the force acting to the right is bigger than the force acting to the left. And so there is a resultant force acting to the right, which is equivalent to 40 minus 25 equals to 15 newtons. And that, like we said, is acting to the right. Now, Newton's second law of motion says that F equals to ma, where F is the resultant force acting on the particle, m is the mass of the particle, and a is the acceleration produced by this force. Since there is a force of 5 Newton acting to the right, we can say that the particle is accelerating to the right. So for B, we say the particle is accelerating in the direction of the 40 Newton force, which is to the right. Looking at the particle, we can see that for the horizontal direction, the particle will not move to the right nor to the left because the forces are the same. A 30 Newton force to the right and a 30 Newton force to the left. But looking at the vertical motion, we see that the force acting downwards is 15 newtons and the force acting upward is 15 newtons. That means there is a resultant force acting downwards, which should be 50 minus 15, and that gives 35 newtons. So the resultant force is 35 newtons, and this is acting downwards. In the same way, according to Newton's second law of motion, whenever there's a resultant force, it produces an acceleration on the particle. And that means the motion will be described as an acceleration downwards. And that is question 2. Question 3. A car is moving along a horizontal level road. The engine of the car produces a constant driving force, and the motion of the car is opposed by a constant resistance. A. Modeling the car as a particle, draw a force diagram to show the forces acting on the car. B. Given that the resultant force on the car is 5,400 newtons in the direction of motion, and that the magnitude of the driving force is 10 times the magnitude of the resistance force. Calculate the magnitude of the resistance. So first, let's draw our force diagram. So that is the particle, and this is the horizontal level road. So first, there's a driving force of F acting this direction. There is an opposing force or resistance, lowercase f, acting in the opposite direction. There's also a weight acting downwards, and the weight W will always be equal to the mass times acceleration due to gravity. And because there's a weight, there is a normal reaction. And this is the force diagram required. For B, if we produce the same diagram here without weight and a normal reaction force, we are told that the driving force is 10 times the resistance force. So let's put those forces in. The resistance force is lowercase f, and the driving force must be 10F. So because we have this situation, and according to Newton's second law of motion, there will be a resultant force. And that resultant force will be equal to 10F minus F. But we are told that the resultant force is equal to 5,400 newtons. And so we can now solve for F. And then that will be 9F equals to 5,400 newtons. So for F, that gives 600 newtons. And this is the end of exercise 10.1. Thank you again for watching, and I'll see you in the next video.